Hi, I'm Alex from Cerbos, and I'm going to walk you through how the Cerbos Authorization Management Platform works and what each piece of it does. Some quick framing before the diagram. Authorization is the layer that decides for any given action, whether it's a person or a system, actually is allowed to do the action it's trying to do. Many teams used to build that logic by hand, scattered across every service, and if you've done that, you know it turns into some of the most tangled, high-stakes code you own. Cerbos is the one platform that pulls it all out into a single place. Let me show you how it all fits together, starting with the basic model. So at its core, Cerbos answers one question through one API call. Anything in your stack, an application, a gateway, a workload, an agent, asks, can this actor take this action on this resource? And Cerbos answers typically allow or deny. 3 inputs go into that call. Firstly, who's asking? We call that the principal. Could be a user, a service, an agent. What they're trying to do, we call that the action, like view, edit, delete, approve, comment. And what they're trying to do it to, so the resource. It could be an expense, a document, a customer record, you name it. The rules that decide that answer live in policy. These are written in YAML, they can be version controlled in your Git repo, and they're kept outside of the application code. So a policy change is just a change to a permission, doesn't need a whole code deploy. The caller hands Cerbos those 3 inputs. Cerbos goes and checks them against the policy, and the decision comes back in about a millisecond. And that's the whole model. Everything else you see on the diagram when you go through is about running that one check in more places and feeding it better context. So let me set expectations before we walk through it. This is the full reference architecture. Every place authorization can live in a large, mature system. And before we go through it piece by piece, here's the short version. You have enforcement points spread across your stack, ways where the checks actually happen. You have the Cerbos PDP is the open source decision engine that answers it. Cerbos Synapse gathers the context each decision needs from your identity providers, your databases, your APIs. And Cerbos Hub is the control plane where those policies are tested, written, shipped, and even every decision is then logged back to. So there's 4 parts, and that's the whole platform. I want to be clear, you probably don't need all of this from day one, and you certainly don't need to roll it out from day one. This is just a shape that typically we see companies grow into over time. So I'll come back at the end to point out where you can actually start, which is actually much smaller than you may think. So for now, let's go and walk through the pieces so you can see what is possible. And then start at the top. So authorization isn't one checkpoint. It's enforced everywhere an identity tries to do something. These spots are called policy enforcement points, the place where you actually make the check, and they sit right alongside your application stack. So on the clients, you might got web apps, mobile apps, IoT devices. Increasingly now we have like AI agents and MCP clients. These can have a version of our decision point that's embedded directly into the runtime. It's a lightweight copy of the Cerbos engine inside the client itself, and it's great for those kind of presentational style logic. Deciding what to show or hide on a form in a UI, like menu items or form fields, based on the user's role. These clients then hit your backend, and where typically the first thing that happens is some sort of authentication. So you have your identity provider. You can run Cerbos right here, and during the token issuance, when the user's token is minted, you can use policy to decide which scopes or roles or claims go into that token. At that point, the request will start flowing through typically a gateway, either a traditional API gateway, where you authorize based on root path, headers, etc., or you might have an AI or an MCP gateway where the policy decides around maybe which tool an agent is allowed to see based on who's driving it. And then behind that, you have your real systems. These are your microservices in Go, TypeScript, Java, .NET, whatever you run. You're also going to have legacy components that you can't simply modify. And these can be fronted by a reverse proxy, which Cerbos can then be used to filter a path based on path, and just importantly, give you a record what was allowed through. And then you might have your MCP servers that are exposing tools to agent. Then you have batch jobs and training jobs acting on the user's behalf, and push it all the way down to the data layer. So for databases and vector stores, Cerbos can generate a query plan, which instead of returning that allow or deny, returns the policy to filter down your query straight to the filter your query straight down to the data level. So you're not overfetching, you're not filtering things afterwards. So all of this typically then sits inside of a service mesh, something like Istio, the layer that manages that service-to-service calls, and you can answer that service-to-service question queue. Based on the policy, should service A be allowed to call service B on behalf of this upstream user? So the enforcement is everywhere. Now here's the part that actually makes it really work. If we go and look at one of these enforcement points, you'll find the same 2 things stacked together. So we have Cerbos Synapse on top and Cerbos PDP underneath. Take the PDP first, the policy decision point. This is the decision engine that I described earlier. The thing that takes those 3 inputs and returns an allow or deny. And it's open source. It runs locally inside of your infrastructure and never over the internet, which is how you get that sort of sub-millisecond answer response time. It exposes the check API, where you give it that principal, that resource, and an action, and some context, and it returns the decision. We also have the plan API. That's the query plan I mentioned. Every decision makes emits an audit log, a record of who asked what and how it was answered. And the PDP deliberately simple about the outside world. It only evaluates policies against the attributes you hand it, which raises the question, where do the attributes come from? And that's what Cerbos Synapse answers. Cerbos Synapse is our context and integration layer that sits in front of your PDP. You write your policies as if every attribute already exists, and Synapse is what makes it true at runtime. Your policies never fetch data themselves. It never knows about a database existing. Synapse gathers that context before the PDP ever sees it. And the enriched data just shows up as normal attributes. And that's important. Take a stale token. You issue a token that's valid, say, for an hour, and the user role gets revoked 30 minutes in. Every system trusting that token is now wrong for the next half an hour or so. With Synapse, you can add an enricher that checks that token's age and past a certain threshold, refetches that live role from your IDP or HR system and overwrites that stale claim before the decision is made. The policy doesn't change. One line of enrichment config did. Or if we look at the resource side context, your policy needs to know about whether an account is a staff account, but the fact lives in a different team's database somewhere and is not in the request. Synapse can be hooked up to go and look it up invisibly to whatever that check does. It does this through data sources. There's native connections for things like Postgres, MySQL, Okta, LDAP, or we can go and hit any API system that makes available. So you're talking about your Okta, your HR. Some of those connectors we shipped, others you can write yourself. You can script it using Starlight, or you can build WebAssembly modules, and they can be version controlled and managed. Orchestration then handles how those systems can speak to each other. And we can also then go and hook into native systems that have authorization checks, things like Envoy and Istio. So Synapse can adapt to your existing infrastructure. You don't need to rewrite your services to adapt it, and it's all backed by a unified cache. And this cache is shared across all your instances, be it a Redis or an in-memory one. So no data source needs to be pre-warned or anything like that. And one deliberate design choice that architects define the enricher, not people writing the day-to-day policies. This means a separate policy routine change can't accidentally hammer a production database. And the whole stack deploys in a drop-in replacement for an existing PDP. Same API, same policy, same config, just with some enrichment layered on top. The context comes in, the PDP evaluates, and the answer is one of those three things. Allow the action, deny the action, or constrain it, returning a query filter to redact fields on the way out, or demand a step-up challenge, those kind of things. And it's not just a yes or no. A decision with conditions can come back. Now you've got Synapse and PDP enforcing the decisions at a dozen points across your application. How do you actually manage all of that as one thing? And that's Cerbos Hub, the policy administration point. The control plane where your policies are authored, tested, and shipped. This is where your identity security and your platform teams work. Inside it, we have playgrounds for authoring policies. We have the audit log coming in that's aggregated from every PDP across your fleet. It gives you observability in every decision, as well as a full CI/CD pipeline for policies. And two ideas drive this pipeline. One is we have policy stores. Think of these as like buckets or folders for your policies, split by how your org is shaped, by platform, by feature, by tenant, and so forth. You then have deployments. These could be QA, production, each one pointed to a different set of those stores. When policies change, the deployment merges those together and runs all your tests. And only if the test passed, does Cerbos Hub roll that out to the fleet of PDPs. If the test fails, the update never ships, and it runs both ways. Policy updates flow down to every PDP, audit logs flow back in. So Cerbos Hub is where you can see any decision, exactly which user tried to do what action on which resource and which version of specific policy allowed or denied it. Gives you that full end-to-end visibility in seconds. Policies get in however you already work. A native GitHub integration, we can pull from your own CI pipeline that your own build, and we can plug in through your own CI steps. Now, the last piece is dynamic policies. So let's say you have a role assignment screen in your product where your customers can define their own roles or conditions. The backend can push those programmatically to Cerbos Hub through our APIs or our SDKs, writing, for example, that each in the customer's own tenant, they can define their own rules. And the same pipeline as before, build, test, deploy out to every PDP. Your end users manage their own policies and permissions in their own scope, and that still flows down to the exact same governance process used across the stack. So that's the shape of it. Cerbos Authorization Management Platform. Cerbos gathers the context. Is Synapse, the PDP makes the decision, locally under a millisecond, and Cerbos Hub governs all that from one control plane. Now back to what I said at the start. The full picture is what mature teams end up at, not where everyone begins. So here's how we recommend you start. Pick one service, add a Cerbos PDP next to it, and write a policy for just that one service. run them in sort of permissive mode first, meaning Cerbos evaluates every request, logs what it would have done, but your existing authorization logic makes the call. Nothing changes in the app behavior. You then just watch those audit logs and compare to make sure you're confident that the policies are right. And then you flip the switch to that service to go to enforce mode. Then you move on to the next service and the next service and the next service. And then Cerbos, one platform adapted to one service at a time. If you want to see it in your own architecture, book a demo and we can walk you through it in more detail. Thanks.